Hello friends. So we have a question involving trigonometric concepts of trigonometry as well as binomial theorem. So in the A part, it is given that 1 minus a cube, and we have to expand this and arrange the terms in the ascending power of a. So you can either use a minus b cube because it is only power 3, or you can apply the concept of binomial expansion, which is a plus b raised to the power n can be written as a raised to the power n plus nc1 a raised to the power n minus 1 into b1 plus nc2 into a raised to the power n minus 2 into b2 plus and so on up to the b to the power n. And the tr plus 1s term is ncr a raised to the power n minus r into b raised to the power r. So using these concepts, we can expand this. So for the first term, we would be getting it 3c0 1 raised to the power 3 and minus a raised to the power 0. The second term will be 3c1 1 raised to the power 2 and minus a raised to the power 1. And our third term will be 3c2 into 1 raised to the power 1 minus a raised to the power 2, plus our last term would be 3c3 and then 1 raised to the power 0 and minus a raised to the power 3. So what we get is 3c0 is 1, so we get 1, then minus 3a, then plus 3a square plus minus a cube. So this is the expansion we get from expanding 1 minus a cube minus a cube. So if we have already arranged this in an ascending order, now let us try to solve the part B. In the part B, by using a substitution for a, we have to show a given expression 1 minus 3 cos 2x plus 3 cos square 2x minus cos cube 2x equals to 8 sine to the power 6x. So if you look closely, this is exactly the same expression written to us. So we already know that 1 minus 3a plus 3a square minus a cube is equals to 1 minus a cube. And if in this equation we place a by cos 2x, on both sides we get is 1 minus 3 cos 2x plus 3 cos square 2x minus cos cube 2x, which is the expression given in the question. It will be equals to 1 minus cos 2x raised to the power 3, and 1 minus cos 2x is nothing but 2 sine square x raised to the power 3. So this will be 2 cube into sine to the power 6x or 8 into sine to the power 6x. Now let us move on to the next part. In the next part, we are given an fx, which if you look closely, it is 4 cos x into 1 minus cos 3 2x plus 3 cos square 2x minus cos cube 2x, which is exactly the same expression which is given in the second part of A. And hence we can simplify this fx is equals to 4 cos x into what is left is this is the same expression, and this can be written as 8 into sine to the power 6x, which we already proved in the previous part. So this is 32 sine to the power 6x into cos x. So this is our fx. Now let us look what operations we have to do on this. In the a part, we have to apply this integration. So we have to integrate 0 to m fx dx, and we have to prove it to an expression. So let us try to integrate this. Now this is the integration 0 to m fx is nothing but 32 into sine to the power 6x into cos x dx. Now we can use a simple substitution, sin x equals to u. So cos x dx will be equals to du, and when x is equals to 0, u is equals to 0, and when x is equals to m, u will be equals to sine m. So our integration can be written as x varying from 0 to m, so u will be varying from 0 to sine m, and this is 32. Now you know cos x can be written as du, so it will be u raised to the power 6, as we assumed sin x equals to 6 into du. So this will be nothing but u to the power 7 divided by 7 into 32, and limits ranging from 0 to sine m. So this will be 32 by 7 into sine to the power 7m. So this is the expression we needed to prove in the A part. Now let us move on to the second part. In the second part also we have to integrate a function fx from m to pi by 2. So we have to integrate it from m to pi by 2 fx dx, and it is given as 127 divided by 28. So now let us see what we can do, and it is also given that the value of m is lying between 0 and pi by 2. So the function fx, as we have already know, is sine to the power 6x into cos x into 32, and limits ranging from m to pi by 2 into dx. So first we will solve this. Assuming sin x equals to u as done in the previous part, cos x dx will be equals to du, and at x equals to m, u will be equals to sin m, and then at x equals to pi by 2, u will be equals to 1. So this is 32 into limits sin m to 1. This will be u to the power 6 into du. So further solving this, we get u to the power 7 divided by 7 into 32, limits from sine m to 1. So what we get is 32 by 7 multiplied by 1 minus sine to the power 7m, and this is given equals to 127 by 28. Now we have to solve it for m. So this is equals to 32 by 7 into 1 minus sine to the power 7m equals to 127 by 28. Now cancelling this 4, and we get 1 minus sine to the power 7m equals to 127 divided by 32 into 4, which will be 128. So sine to the power 7m is equals to 1 minus 127 by 128, or 1 by 128. So what we get is sine m is equals to 1 by 2. Now the value of m will be equals to pi by 6, as it is already given that m lies between 0 to pi by 2. So this is your final solution, and for more such questions, do visit our website and register for detailed explanations and solutions. Thank you.